Let us study about amphoteric oxides. Some metallic oxides exhibit a dual behavior. They show characteristics of both acid as well as basic oxide. Such oxides are known as amphoteric oxides. Examples are zinc oxides and aluminium oxide. Such amphoteric oxides, or you can say they react with acid as well as alkali. For example, Al2O3 reacts with acid as well as alkali. You can see here Al2O3 reacts with HCl, which is an acid, in the presence of 9H2O. It produces a complex AlH2O6 plus 3 and 6Cl minus. Or you can see that Al2O3, when reacts with the alkali sodium hydroxide in the aqueous medium, it produces the Na3AlOH6 kind of complexes. So this is how we can really understand or study about the amphoteric oxides. We even have neutral oxides. There are some oxides which are neither acidic nor basic. They are called neutral oxides. The examples of neutral oxides are NOCO and N2O, that is nitric oxide, carbon monoxide, and dinitrogen oxide or nitrous oxide. Now we are going to study about ozone. Ozone is an allotropic form of oxygen. It is an allotrope of oxygen. Ozone can be dioxide of oxygen. You can see OO2, that is your ozone, like SO2. Ozone is very reactive to remain for long in the atmosphere at sea level. So ozone is not stable at sea level, but it is stable at higher altitudes. Ozone is formed from atmospheric oxygen in the presence of sunlight at a height of about 20 kilometers from the sea level. You can easily understand that it can be formed only at the height of 20 kilometers, so it is stable even at that. The ozone layer, the layer of ozone almost available at 20 kilometers away from the Earth's surface. This ozone layer protects the Earth from excessive concentration of ultraviolet radiations. We call them UV rays. So this is how this ozone layer is very important for us. And depletion into the ozone layer is a one of the problem that scientists faces nowadays. Now we'll study about the preparation of ozone. When a slow dry stream of oxygen is passed through a silent electrical discharge, remember that the electrical discharge must be silent. Conversion of oxygen to ozone occurs, and that is 10%. Please remember, my dear students, that whatever the ozone produced, it is maximum up to 10%. So only 10% ozone is produced by the silent electrical discharge. And remember that the product which is produced by the silent electrical discharge is known as the ozonide oxygen. So you can see that 3O2 is converted into 2O3 in the presence of silent electrical discharge. That is what we can write here. We can write here silent electrical discharge. Here delta H is equal to plus 142 kilojoule per mole at 298 Kelvin. That means delta H is positive. Since the formation of ozone from oxygen is endothermic process, because delta H is positive, so the process is endothermic, heat is required for reaction. It is necessary to use a silent electrical discharge in its preparation to prevent its decomposition. So if we give little more energy, or if the electrical discharge is not silent, this ozone again decomposes back to 3O2. So we should have the silent electrical discharge. It is very much necessary. If concentration of ozone is required more than 10%, a battery of ozonizer is used. It is a device for the production of ozone, and pure ozone can be condensed in a vessel surrounded by liquid oxygen. So this is how we can understand about ozone, and ozone is produced in more than 10% concentration. Boiling point of ozone is 161.1 Kelvin. If we need up to 10% concentration of ozone, we should use silent electrical spark. But if we want concentration more than 10% of ozone, we should use the battery of ozonizer. I hope, my dear students, you are enjoying your studies. Happy learning.